let f of x equal x cubed minus 3x squared plus 3x minus 2. Calculate the derivative f prime of x. So using the power rule, we would have 3x squared minus 6x plus 3. And the second derivative would be just as straightforward with the power rule. So that is 6x minus 6. On what interval is f increasing? Well, the function f is increasing whenever its first derivative is greater than 0, and it's decreasing whenever its first derivative is less than 0. So to determine that, we need to test some intervals and just see what's happening with the derivative. We would need to know where the derivative could change from increasing to decreasing, and that can happen whenever the first derivative is 0 or undefined. We don't have to worry about undefined values because this is a polynomial function. Polynomial graphs don't have any undefined values, but they do have zeros. So let's look for those. Now if I factor out a common factor of 3, that's going to make factoring a little easier. This would be x squared minus 2x plus 1. And if I factor this, I have x minus 1 quantity squared. So that tells me I have a 0 at positive 1. Now, on each side of positive 1, I need to determine if my function is increasing or decreasing. So I'll pick a value on this interval and on this interval, and then just plug that into my first derivative. Now, one thing I'd note here is whenever I take any value minus 1, the result of that could be positive or negative. But I'm going to take that result and then square it, so that's always going to result in a positive value. So it really doesn't matter what number I put in here, I'm always going to get a positive out because then I'm just multiplying by 3, which is still positive. So if you're uncomfortable with that kind of an argument, then just plug the values in and verify. They both are going to be positive, but because of that square, you can be assured of that. So what that means is my function is increasing on the interval from negative infinity to positive 1, and then again from 1 to infinity. Now, do be careful not to put in negative infinity to positive infinity. It's tempting because these two intervals are sort of joined together, but the problem is we're not including the point at 1. What we say there, it's the function's neither increasing nor decreasing there. So at that particular point, what we do is exclude it from either of these domains. So that's the correct answer there. On what intervals is f decreasing? So f is decreasing on a null set. We don't have a symbol for a null set here. So what you're told online is to just put that it does not exist. So there's never an interval where this thing is decreasing. On what intervals is f concave downward? Well, f is concave downward whenever the second derivative is less than 0, and concave upward whenever the second derivative is greater than 0. So just like with the first derivative, to determine intervals of concavity, you do the exact same thing, but just with the second derivative function. So we take the second derivative, set it to 0, and there's a common factor of 6 there. So positive 1 is again a point of interest here. And what I need to do now is just test values on each side of 1. So 0 and 2 are great. If I plug 0 in here, this would be 6 times negative 1, which is negative. So I'm concave down on this interval from negative infinity to 1. And then if I put 2 in here, this would be 6 times 2 minus 1, which is 1. So that's a positive value. So that tells me this interval I am concave up. So from 1 to infinity.